So I want to go over adding vectors. This is day 2, and I know we're struggling a little bit with angles and finding the angle. So I want to review 4 critical angles that we want to look at and use to figure out the angle of rotation. So if we rotate from the positive x-axis to the positive y-axis, that's a 90-degree rotation, all right? If we rotate from the positive x-axis all the way to the negative x-axis, that's 180. That's a half a turn, right? This is a quarter turn. This is a half a turn, okay? So if you rotate 180 degrees, you've rotated a half a turn, okay? 270 degrees is you start on the x-axis and you rotate to the negative y-axis, okay? And that'd be a 270-degree rotation, okay? And then if we come all the way around, that's a 360 or 360-degree rotation. Okay, and so we're going to either add or subtract from 90, add or subtract from 180, add or subtract from 270, add or subtract from 360. And a lot of times when we do the reference angle, all right, we're going to use 180 degrees, 90 degrees, and 360 degrees. Okay. So for this next one, okay, I'm going to do both of these 2 different ways. Okay. So to get angle theta, what we can do is we can take our angle theta and we can go all the way to 180 degrees. And this is what I've been talking about. If we go all the way to here, this would be 180 degrees, but that's too much, right? We're stopping before we hit 180. And we know the angle that we go past what we're trying to find. So what we need to do is back up this angle, okay? So what that would be is it would be 180 degrees, and we would need to subtract 28 degrees because we need to get it 28 degrees smaller, okay? So that would wind up being 152 degrees, okay, if you subtract those. Okay, so another way to get this is if this is 28 degrees, I know this angle right here, this acute angle, which is an angle less than 90, right? This angle right in here, and I'll mark it here, and this 28-degree angle, they always have to add up to 90 degrees. So we could figure this one out because we could take 90 degrees, the whole, and minus the 28 degrees, and what we would get is 62 degrees. And I know these are perpendicular to each other, so then I know this is 90 degrees. So a second way of getting this is just to add the individual angles, okay? So this is 90 plus 62 degrees. Which gives you an angle of 152 degrees. Again, I don't care which way you do it, we just got to get these angles correct, okay? All right, so now this one over here, okay, one way to do it is, okay, we can go all the way, and we don't know any of these angles. We know, well, we do know this is 180 degrees, but then we would need to know this angle right here, which we don't have, okay? So in lieu of that, we could come all the way around and go all the way to here. So we have a 90 here, a 90 here, and we go another 90 to end up on this negative y-axis. And what we really have, okay, is I'm going to go all the way to 270 degrees. Okay, I'm going to slide this. So I'm actually thinking about this angle right here to get this one. So I'm going all the way past it now, right? So this one went past it, but I got to back up. So for this one, my angle theta would be 270 degrees minus 23 degrees. Okay, and if we take 270 degrees minus 20 degrees, that would give me 100, or not, sorry, not 100, 247 degrees. All right, another way we could do it is we know that we know this is a right angle and we know this is a right angle. So those are two 90s, which would make 180 degrees. And then we could also figure out what this angle is right here, because once again, I know that these two angles add up to 90 degrees. Let me slide this up a little bit. So I know these two angles add up to 90 degrees. So I could figure this one out by taking 90 degrees and minus 23 degrees, okay, which would give me 57 degrees. 67 degrees, sorry. Okay, it should be 67 degrees. I was trying to do math in my head and I made a mistake. Okay, so 67 degrees, because 67 degrees and 23 degrees makes 90 degrees. Okay, all right. So now, how could I get this one? Okay, so we could take our angle theta, we could take 180 degrees and add the 67 degrees, because we go all the way to here and then that much more. Okay, and so 180 degrees plus 67 degrees would give me an angle of 247 degrees. Okay, so sometimes you're going to have this situation, and this would be this one right here. You would get in a description like 23 degrees west of south. Okay, and this one you could get by saying 28 degrees north of west. All right. So those are just descriptions. I'd rather you not describe it. Okay. I'd rather you give me the actual angle we have to rotate around, like the 247 degrees, or in this case, the 152 degrees. So what I want to do with this one is take this vector u, which is 47 meters per second directly south, and v, which is 75 meters per second at 20 degrees west of north. Okay, so this is a direction. Well, actually, both these are directions. Okay, so we want to draw a diagram because this is a verbal description, and so is this. We want an actual angle, the actual angle of rotation or the direction angle, in order for us to figure this out. Okay, so we want to draw a diagram for this one. Okay, and so for this one, we're going, this would be north, and this would be south, and this would be west, and this would be east. And it's saying it's all south, right? So we're going completely south. So we're going all of it going that direction, okay? Now, because we're going south, we should know that south means negative. So this is going to be a negative velocity. So this is negative 47 meters per second. And there's no horizontal part to this. So when we go to write our horizontal component, we should realize, oh, it's going to be 0. We don't go left or right at all. We don't go west or east. We're going straight south. So that means this would be 0 meters per second. And then my use of y, well, it's all vertical, right? So since it's all vertical, that would be negative 47 meters per second. If you want to continue with the sine and cosine, okay, you could, because this would be the same as negative 47 meters per second. And this angle of rotation that we get right here would be 270 degrees. Okay, so we could take negative 47 meters per second and we could multiply it by cosine of 270 degrees. You know what? I said negative 47, but I should have said 47 because our vector is 47 meters per second in the southward direction. So this should be positive 47. We would get the wrong answer if we wrote negative 47. So I'm going to rewrite this. So this would be 47 meters per second cosine of 270 degrees, which would give you 0 meters per second. Okay, and then this one would be 47 meters per second sine of 270 degrees. Okay, this would give you negative 47 meters per second, and this one would give you 0 meters per second if you actually put it into your calculator. Okay, so for this next one, 75 meters per second at 20 degrees west of north. Okay, so here we go. So we're going to draw a diagram. Okay, and we know here's north, and this is west, and this is south, and this is east. And we know we're going to rotate towards the west from north, and we're going to rotate 20 degrees. So that makes this angle right here 20 degrees. Okay, so what's the angle that we would need to rotate? Because that's the part that's going to be important here. What is this angle that we need to rotate to get here? Well, we know from the first four angles that this is 90 degrees right here, and then plus the 20. So my angle theta, I'm gonna grab a green color. My angle theta would be 90 degrees plus the 20 degrees. So that makes my angle 110 degrees. So with that said, this angle, whoops, I meant to grab bullhead. Sorry guys. This can be rewritten as V is 75 meters per second at it's 110 degrees. And then that's going to allow me to write V sub x, which is 75 meters per second cosine of 110 degrees. And then V sub y, which is 75 meters per second sine of 110 degrees. Okay, so that's my horizontal component and vertical component, because this vector right here is going to be made up of a horizontal part and a vertical part. Okay, so when I combine these, I have to add the horizontal parts together. Okay, so r sub x would equal the 0 meters per second plus the 75 meters per second cosine of 110 degrees. And so that would give you r sub x. And I want to go to 2 decimal places, and I'm going to grab my calculator, making sure these take a while sometimes. We've got to make sure we're in degree mode. Okay, so this would be 0 plus 75 cosine of 110. And this gives you negative 25.65. So negative 25.65. So that's the horizontal component of my resultant vector. That's why I'm calling it r. Okay, and then we need to find r sub y. And r sub y we would get by taking the vertical component of u, which would be the 40, or we could just say negative 47. So negative 47 meters per second, because it's all that one, it's all vertical, right? And then plus 75 meters per second times sine of 110 degrees. And so putting this into my calculator, all right, we would type in negative 47 and then plus 75 sine of 110. And we get 23.48. Okay, so that means that I'm needing to draw a diagram where I go left and up. Okay, so I'm going to draw my diagram. I'm going to slide this up a little bit, because now we have our horizontal component and our vertical component of our last vector. So this is north, and this is south, and this is west, and this is east. And I'm going to go 25.65 to the left. So negative 25.65 meters per second. And I'm going to go up 23.48. I should have had meters per second on that. And go up 23.48 meters per second. And so I need to go in this direction. From here, I'm going to be going in this direction as a result of these two vectors. Okay, so now what I need to do is I'm going to need to figure out what this angle is right here, theta. And I'm also, before I get that, I'm going to have to get this angle alpha. Okay, and even before that, I need to get my r right here. Okay, so r is just from the Pythagorean theorem. We're going to square root our horizontal piece, which is negative 25.65 squared plus 23.48 squared. And we'll just put that into our calculator. Trying to get the glare off. Okay. And so square root, and then parenthesis, and then negative 25.65 squared, and then plus 23.48 squared. And so we get 34.7 or 34.8, because I want you to round this to one decimal place. So 34.8 meters per second. So that's how fast we're going. And now we got to get the direction that how fast that's that velocity right there, that speed, right? I want to know what direction are we going with that, okay? And so we're going to go and we're going to find this angle alpha, and alpha is equal to tan inverse of 23.48 divided by 25.65. Remember, both these have to be positive. And when we put that into our calculator, we get 42 degrees. Okay, so the angle of the triangle is 42 degrees. So I know this is 42 degrees. And I know if I go all the way over to the west, that'd be 180 degrees, and that'd be too much rotation. So once again, I'm going to back up. I'm going to subtract. So my angle theta is going to be 180 degrees minus 42 degrees, which gives me an angle of 138 degrees. Okay, so another way to do it, okay, I did it by subtracting this 42 degree angle from 180. Another way to do it is to figure out this angle right here that I'm pointing at right there, where I put the dot right there. Get that angle, okay, by taking 90 minus 42, and 90 minus 42 is 48. So this angle right here is 48, and if you take 90 degrees plus this 48 degrees, you would get 138 degrees. Okay, so two ways to describe this. We could say 34.8 meters per second, okay? And the direction, let me zoom in on this a little bit. And the direction we're gonna go is at 138 degrees. You could also, okay, that's straight mathematical way of describing the velocity and the direction. Okay, a descriptive way is to say 34.8 meters per second, and then we could say 42 degrees, and we're rotating from the west towards the north, so you'd say 42 degrees north of west. Okay, and so really where we're going with this on Thursday and Friday is we are going to pull the vectors out of a verbal description, okay? And we're going to be doing the same thing, but it's just going to then what we're going to have to do is get the actual vectors from that verbal description from a problem. Okay, and that's it for this unit then. Okay, so we have just this week and we'll be done. All right, you guys. Okay, that's it for today. We'll meet back and then we'll go maybe do like one more example together. Okay. All right, you guys.